With Chapella upgrade round the corner, we want to touch on every important piece of information that can help you understand the Ethereum protocol. If you heard about Builder API and want to learn about its importance in Capella upgrade on consensus layer client, continue listening. Welcome to Peep and Eep. I'm Pooja Ranjan with the first episode after completing a century on this Ethereum educational series. Today, we are going to talk about Ethereum Builder API. To learn more about what it is and what role does it play in helping withdrawal with Capella upgrade, we are joined by Gajendra Singh. Welcome, Gajendra.
Thank you, Pooja.
For people who aren't aware, Gajendra Singh is an Ethereum client developer, recently joined the EIP editing team as well. He has joined us on Peep and Eep a couple of times before to talk about Lodestar and Ethereum JS. If you want to learn about these clients and others, check out our Know Your Client series on Peep and Eep. Well, as per today's topic, Builder API, the term was mentioned in almost every CL meeting right before the merge, and I'm curious to learn more about it. So without further ado, let's peep in.
Hey guys, we are here to talk about Builder APIs in Capella. As you would be more familiar with the more popular name MEV Boost, and as you know that MEV Boost is used to uh, build highly profitable blocks on Ethereum blockchain. Some arbitrage opportunities that are out there, and uh, they submit private bundles which are not visible to everyone. And if a validator includes those private bundles, the payout to the validator is quite high. So the way this works is that MEV Boost is a sidecar to Ethereum local execution client. So a validator will request to build block on local execution client as well as on a builder, and it will then basically select one of the blocks, and then it will basically propose it and include it in the blockchain. And as a result, the validator should get a good payout. So if you look at the top level flow, what really happens is that a validator needs to register itself to the MEV Boost relay and MEV Boost builders, which is like a marketplace. So there are people who are basically submitting these private bundles, and they are sort of bidding that okay, this is the price they would be happy to pay for that bundle. And what really happens is that validator also registers themselves to the to the builders, and so the flow starts with registration of the builder, registration of the validator to the builder, and when the time for proposal comes, a builder will a validator will ask for a payload header, which which the builder will reply and provide. And that payload header will not have any transactions in it, because the entire purpose of MEV Boost is of MEV Boost slash builder is to hide the transactions until they don't need to be hidden anymore, which is basically when the validator has actually signed the payload, which is generally called a blinded block. And when that block is signed and submitted, then a builder actually constructs a full block and publishes to the network, as well as provide the full payload to the client, which can also construct and publish. So on a high level, these are the APIs that are out there. So one is to request, uh, one is to register yourself. Then the second one is to get a payload header which has transactions route instead of transactions, because again, the transactions should be hidden till the block has been signed and submitted to the builder. And the third, that is where the third API comes in, where you construct a blinded payload which has transaction route instead of transactions, and you give it to the builder, and basically you get a full payload. And the last one is just to keep polling this what is the status of the builder, because obviously you wouldn't want to uh, interact with a builder which is down and sort of risk losing your proposal. So as we discussed, there are two major parts of how the Builder API works. One is build blinded block, and then the second is publish blinded block. In the build blinded block, so when the validator calls to build a blinded block, then as we discussed before, builder will reply with an execution payload header, which has transactions route and it has some bit value. And when you submit a blinded block, which has transactions route, then the builder will reply you with an execution payload that has full transactions, which you can again construct to use to construct the full block and publish it. So what is new in Capella, right? So everything else is totally the same, but additionally now with transactions route, you also get withdrawals route, which are basically withdrawals, root of the withdrawals in the block. And actually this withdrawals route is not really required in the sense that uh, the withdrawals in a block are very deterministic. And even if the builder does not provide you with withdrawals route, you already know what withdrawal route should be. And so basically this is how you check whether when the builder has given you withdrawals route, you can match it with what you locally expect it to be. And again, moving to the second step, when you actually submit that blinded block to the builder, then it gives you full execution payload, which has transactions as well as withdrawals. So everything else remains the same. All the APIs are the same. What really changes are these extra parameters that you get in the data and that you submit. So what really is the new thing that will happen in Capella is that what is a more interesting thing that will happen is now is that even execution will start giving you uh, giving you the block value. But right now what really happens is that builder gives you bit value along with the execution payload header. But when you call local execution and get a payload from it to include it in the proposal, you only get transactions. You don't really get any block value that is out there. So you can't really compare that, okay, what to choose. A validator basically can't really make a selection out there. Most of the times what you really do is that you put a min bit value on your local MEV relay, which basically uh, filters out the blocks which don't pay you that much. But right now with Capella, what really happens is what will really happen is that a new version of get payload is being introduced on the execution clients, and those clients which support this get payload v2, they will all they will also give you block value with it, and you can directly compare it. A validator can directly compare it with the builder bit value and basically select whatever is more profitable to it. To do it in Lodestar, you just need to provide an extra arg, which is minus minus builder dot selection max profit. And it will basically, Capella onwards, it will start making the selection based on what is paying more. And this is also important not only for profitability, but also for censorship, because a lot of the builders out there, they are censored and they basically will not include some particular kind of transactions. But execution clients don't have that restriction, and they tend to include all the transactions that are in their mempool. So what really will happen is that if your local execution client will build a better block because of the transactions that the builder is trying to exclude, then basically you are also defeating censorship with this particular upgrade. So what else is desirable from the builder? I mean, builder gives you transactions, it gives you transactions route, it gives you withdrawal routes, and obviously it will give you the full payload as well. But when you are trying to build a block, a blinded block out from the builder, by getting the header, you also want a proof of the payment, because right now everything is on that. So there is very high trust level on the builders that you are using, that whatever bit that uh, they are uh, they are they have included in their response, that is a bit that you would get. And there is some level of trust out there because proposals are very few. Like, a validator is getting to make 4 proposals, so each proposal is very valuable, and you would want that. uh, Basically, you don't really have to trust that much, and you can verify. So earlier, people would be able to verify in so when an execution client is making a block, you will basically provide it a free recipient to which all the fees will go. But when a builder really gives you payout, it gives you payout in form of a transaction. So it is not that straightforward, and you would basically expect that there is some proof of payment, because if there are no transactions at the time when you have to make a decision, and this is before you actually sign the block, and you don't have any transactions at the time. So it's pretty important that builders should start including proof of payment, proof of the bid value into their blocks, which can be cryptographically verified on the beacon or on the validator client. If we look at the ground readiness for the withdrawal builder, for the Capella builder, uh, basically, I feel that we have reached to the point where we are ready. For example, MEV Boost is being tested on GGang testnet, and here is a block that was proposed by Lotsa Geth on GGang testnet, which was an MEV Boost block using the same builder flow that we talked about. So what are the considerations that we have for this particular flow? Builder as as a component in the Ethereum ecosystem is a third-party component. So what we really want to do is that we want to test not only a good flow, where happy flow, where everything works, but we want to test the flows where builder doesn't work, and Ethereum blockchain carries on. So what is this? What this particular feature is called breaker, and most of the clients have this. And what really happens is that if, for example, the blocks uh, from the builder are malformed in some way, uh, so the clients on the network can see, okay, the proposals on the networks are failing, and they basically switch off the builder, and they propose using only their execution client till the network health is back up. So most of the clients have this, and this is also being extensively tested. Another thing that requires consideration is that if, for example, builder gives you a bad block which are able to test locally before you sign it, so you should be able to fall back on the execution client block. And this again is a feature which most of the clients will be having, but again, it is to be extensively tested. And obviously the third thing is to uh, to basically aggressively verify that the withdrawals route that the builder is sending you is the expected withdrawals route that your local client will say it should be, because withdrawals are very, very deterministic. There is no if and but over there. There's no chance to have a different withdrawals at any particular block. So this should be aggressively verified before even considering a builder block. So again, rigorous testing is going on. There have been withdrawal devnets on GGang network, and they are shadow forks, mainnet shadow forks, and for which kudos to EF DevOps and all the client teams. And now the Hive tests have come out, which basically test whether all these conditions, how the client is doing in all these conditions, whether there is a circuit breaker that is happening, or is there a fallback on the local execution, or all they matching withdrawals route with the expected withdrawals or not. Because happy flow is one thing, we have to make sure that the Ethereum blockchain carries on even if the builders are not ready, and even if they give us malformed blocks.
Right. Thank you so much. And the presentation was really beautiful. I love the builder flow or sharing the functioning of protocol. I know our podcast listener may have a hard time following it on audio only mode, but I'll make sure to add the presentation link and a video for reference. So yeah, thank you so much for that. Well, I have a few questions for you. Some of the questions are on high level on a Builder API. So let's start with why Builder API. So building block, as we understand, is a key component of blockchain. In my mind, avoiding trust assumptions is the best way forward to provide a higher security to the network. But we know the Builder API requires a higher trust assumption than it was proposed in PBS. And yet we focused on building this API. Do you have any thoughts on why choose Builder API?
I mean, ideally everyone in the Ethereum ecosystem would recommend you not to choose Builder, right? Not to choose MEV Boost, because obviously that part of the component, again, as I have said, is a third party component if you consider in terms of Ethereum ecosystem. And what really are the first party components are your consensus layer and the execution layer. And so again, when basically you have now asked a third party to provide you a block, and they will say, okay, they will do an X payout on it. And so there are two things, whether where you are placing your trust in them. One is that obviously they will pay you out, because right now no payments proofs are included. And second, they have included all the transactions that are there, and there is no censorship that is going on. So basically what it really means, that you are also trusting that, okay, these guys are giving you a block which carries the full value. So there are two places where you are really placing the trust. Everything else you are able to verify, because when you have transactions root, you can basically verify that the rest of the state that is being generated is all good. But again, you don't have any uh, view into the transactions before you actually sign and submit it to the builder. So you are therefore placing a lot of trust into the builders for doing the right thing. And that is something um, uh, where changes are basically being proposed. One is, again, for the builders to include payment proofs, and the second thing is there are some transaction lists that could be provided to the builder to include those transactions and make sure that no censorship can happen at the builder level.
Thank you. We know when Builder API was introduced, it was introduced as a temporary solution to like high fixed cost of efficient validator with a high trust assumption. Now with this Capella upgrade, we have added further improvements to help out with the withdrawal. I see a question here in chat. James, if you would like to ask the question here related to withdrawal.
Yeah. How does the builder ensure that withdrawals are included?
So if you look at the response that the builder gives you, so when the proposal time starts and you ask builder to give you a header, which is basically an execution payload header, so it has to give you a properly formatted execution payload header. And for the Capella hard fork, you will expect it not only to give transactions root, but also the withdrawals root. And as withdrawals that are there that are to be packed in the block, so they are 100% deterministic. And so you can easily verify whether the withdrawals route match with the expected withdrawals route. So you can locally calculate that and sort of match it.
Thank you. So we were talking about specs testing earlier, like the changes that has been introduced with the Capella upgrade. We all know specs testing goes without saying for Ethereum. And for every minor changes, we want to do double, triple checks, be sure about it. We know that MEV Boost is already on Zhejiang testnet. Could you maybe talk a little bit more about the match withdrawals root feature? Is it already on Hive or any other DevNet?
Yeah, so all the clients, so doesn't matter whether you use builder or an execution. So when a new block comes in, it is very deterministic what withdrawals will get packed into it, and it is sort of part of the consensus. And so the next, so if you mint a block and other clients are trying to import that block, they will they have to check, and it is part of the spec that the expected withdrawals should match. So you locally calculate what the withdrawal should be, and basically then you have to match. And similarly for the builders, since you don't know what the withdrawals are, but you can match with the withdrawals route. And obviously when you get the full payload, you will construct it, and again it has to match that, okay, these are the withdrawals that match with this withdrawal route, and these are the transactions that match with this these are the transactions that match with this transaction route. So there are spec tests that are out there that will basically feed you blocks, and they will basically make sure that you catch the error if there is any discrepancy in the withdrawal route. Also, the uh, state also has a flag which is directly dependent upon what withdrawals are packed into that block. So there is so there is a flag to determine what is the next eligible validator for the withdrawal. And so there is some state matching that is also going on. So not only it happens in at the block level, but also at the state level. uh, there is some match that is going on, and if the clients are not in agreement, obviously the consensus will break. And so we started, when all the testing started, we saw some of these things, and then obviously we client's team went back and fixed all those issues. And then we have got these spec tests, and we have got uh, um, tests that are happening on Zhejiang network. We have the Shadow Fox, and now we also have the hype test, which basically tests the same thing.
So talking about this Hive test, we got to know that Builder API circuit breaker testing is also going on that. Does it also cover the fallback on local execution?
Yes, it covers the fallback on the local execution, because when the circuit breaks, then basically local execution has to pick it up, right? So it does cover that thing, but even without the circuit breaker getting triggered, for example, a client which is a validator, which is basically making a proposals, for example, Lodestar, it will start two flows. It will start a flow with a builder, as well as it will start a build block flow with the local execution. And if the builder is failing because, for example, it didn't give withdrawals route, or it gave a malformed withdrawals route, then the local execution block will be picked up. And I think these are the tests which are out there right now. What Hive is testing is that, okay, whether the circuit breakers are coming in to play, and if they are coming into play, whether the local execution client is taking over or not. Um, but even without the circuit breaker coming into play, the local execution client can basically take over and say that, okay, if a bad block is being given to you, and if you can sort of detect it pre-signing it, uh, because sometimes even a state in the block can be malformed, which you can't really figure out unless you execute the transactions. And since you don't have the transactions before signing, it is not possible to evaluate that. So unless that is the condition that is out there, you will be able to figure out whether you are getting a good block or a malformed block. And if that is the case, then basically the validator should pick from the local execution. And most of the clients, including Lodestar, we have those test cases running in our CIs. And so I don't really think that, I think this is well covered with the current testing that is going on.
Awesome. That is always helpful to know. All right. I have a question about the future of Builder API. So as we know that it was added as a temporary solution before the merge, right before the merge. And we know that PBS at the time couldn't have been added because that required some modification to the beacon chain. Now that Robust Incentive Group, RIG, a division of Ethereum Research, is working in the direction of getting more information on PBS and having it in a better place, do you think PBS will replace Builder API in future upgrade?
I mean, as of now, it doesn't look likely, but because what really is happening is that what all these builders they have come up as some sort of a marketplace where people submit private bundles, right? And then there are validators which are hooking up to that. So there is some network effect that is going on over there. Whether the new system will be able to overcome that network effect, and how actually the logistics of people submitting their private bundles, because obviously nobody wants somebody else to front run their orders when they are trying to extract arbitrage out there on the blockchains. So that is something that I'm not sure of how it will work. And if there is, I mean, there is no clear solution onto that. And so it is more a problem of the UX in terms of the user flow rather than technical challenges. Maybe some cryptography in terms of zero knowledge proofs can come over there and sort of help this entire process and make sure that people can submit private bundles and they don't really have to go to some proprietary marketplaces to do that. So that would be awesome.
Right. I mean, I don't see PBS Proposer Builder separation to be ready right away. I do not even see that coming up with the Cancun upgrade or Cancun Deneb upgrade. Yeah, this could be maybe more in a long term. Yeah. All right. For people interested in learning more about Proposer Builder separation or PBS, check out episode 93 on PBS with Barnaby Manath on PPenny. All right, it's time to wrap up. Is there anything that you would like to add or share with the Ethereum community?
Yeah, so what I would like to share is that please go to clientdiversity.com and look at the clients that are out there and pick up a minority client combination and run it. And me belonging from the Lodestar team, I would definitely bet for Lodestar. And as you can see, Lodestar is also Capella ready in terms of all the features and in terms of builder flow as well. So please don't hesitate and try it out on testnet. And if you like it, then on mainnet, go for it.
Absolutely. And to add on here, Ethereum cat herders are currently running a survey on client diversity in which we have options for you to share what you're expecting from your client, both on execution layer and on consensus layer. So if you haven't taken the survey, consider taking out time and respond to the survey to let your client provider know what is your expectation, and also do not forget to kudos them with whatever feature you are enjoying. The link will be available in the description. So yeah, check it out. Gajendra Singh, we appreciate you taking out time to talk us about the sidecar to Ethereum chain. I hope to see you again on show with a different topic.
Thanks, Pooja. Always pleasure to be here.
According to the Ethereum Builder API specs repository, the Builder API is an interface for consensus layer clients to source block builds by external entities. The operational functioning does not affect users or validators directly. However, understanding the workflow increases the transparency and the trust on the robust Ethereum blockchain. How do you like today's non-EIP episode? What topic you would like us to cover next? Let us know in the comment below. If you want to learn about latest Ethereum research topics, subscribe to Ethereum Cat Herders YouTube today. Reach us at eCatHerders Discord to follow the amazing world of Ethereum cat herding. We'll be back with another interesting Ethereum topic, so stay tuned and keep sharing your love with Ethereum Cat Herders. Cheers.